Welcome to today's lesson. It is July 22nd, and this topic is one that I've seen a number of you working on. And so I wanted to cover how to use the Pythagorean Theorem to find the side of a triangle. And so with that, a couple of details that we have to take into account as we look at these problems. First, they're going to tell you which of the trig ratios you're going to be finding. What goes along with that is you need to know which sides are included in that. So when you're talking about sine, you will need to find the opposite divided by the hypotenuse. When you're finding cosine, it will need to be the adjacent side divided by the hypotenuse. And when you are finding tangent, you'll need to find the opposite side divided by the adjacent side. Most of you have probably learned the phrase SOHCAHTOA, S-O-H-C-A-H-T-O-A, and some people like to write division signs in between there. And some people like to underline the S and the C and the T, so you can do whatever you want in order to help you remember. But that is one of the most common ways that you'll see people remembering which sides belong to which ratios. As a reminder, this only applies to right triangles. Every right triangle has the same relationships because of what happens when you make one of the angles a right angle here. These relationships always exist. And so, for this particular problem, it's asking us to find tangent of theta. Theta is right here. This is the angle that they have set as theta. They could have picked this top one as well, but they decided to go with the bottom one. And so for this problem, we need to find which side is opposite of theta, which side is adjacent to theta. Now, as far as opposite, it may be helpful, well, really, and adjacent. It may be helpful, first of all, to identify the hypotenuse. Two ways you can think about it. Hypotenuse is always the longest side. It is always the longest side. And it's always across from the right angle. So here's my right angle down here. Across from that is my hypotenuse. That's my hypotenuse. And that has nothing to do with where theta is. That is always true no matter what. That is always across from the right angle, and it is always the longest side, 100% of the time when you're talking about right triangles. So with that, I know that's the hypotenuse. The only other two sides available are an opposite and an adjacent. Opposite of theta is going to be across the triangle, so this was going to be opposite. Adjacent means next to. So anytime, and that's true for math and life, if the house that's adjacent to you, wherever you live, the house that's adjacent to you, that's your neighbor, the ones that are right next to you. And so this side down here will be my adjacent side. Since tangent is the ratio that they are asking us for, I need to find the opposite side and the adjacent side. The nice part, I already know the opposite side. I know the opposite side is 12. So I already have one of them just by looking at the triangle. This is where the topic can get difficult. They ask us to find the missing side. I have to use the Pythagorean theorem in order to find that. Pythagorean theorem is a squared plus b squared equals c squared. C is always the hypotenuse. And hopefully this makes sense. The hypotenuse is always the longest side. That's why it's always the sum of the other two. It's always the sum of the other two. That's what makes it the longest. Well, you think about it, makes it the longest, or it's addition because it's already the longest. But that is always the hypotenuse. The other two don't matter. which one is opposite, which one is adjacent, it doesn't matter. But if I were to fill in the numbers that I know one of the sides is 12. The other side I don't know, and I know the hypotenuse is 13 squared. So I'm going to have 144 plus b squared equals 169. I'm trying to get b by itself, so I'll subtract 144 from both sides. I'm left with b squared is equal to 25. And then the opposite of taking to second power is to take the square root. Therefore, I end up with b is equal to 5. Now, when we take square roots of things, a lot of times we will include the positive and negative answers. In this case, there is no need because length will not be negative. Length will be positive, and so I only need to worry about the positive 5. Now that I know that that side right there is 5, my adjacent side is 5 units long, I now have enough information to write my final answer. Tangent of theta is equal to opposite over adjacent. And that is my final answer. So I did have to use the Pythagorean theorem in order to find the missing side. And that is how you use that. Let's look at another problem. What you notice is that it's not always tangent that they're asking for. So we're going to just write a little refresher here. SOHCAHTOA. They ask for sine of theta. So this will be what I'm using. So I need to focus on the opposite side and the hypotenuse. Well, if this is theta down here, opposite of that is 5. I know it's going to be opposite over hypotenuse. And the opposite I already know is 5, just from the picture. Now the hypotenuse is the side that's missing. And so I'll need to use the Pythagorean theorem in order to solve for the hypotenuse. Which side is always the hypotenuse, A, B, or C? It is C. So the 4 and the 5 don't matter if they are A or B. Those are interchangeable. I'll go and write 4 squared plus 5 squared is equal to C squared. 4 squared is 16. 5 squared is 25. And that is equal to C squared. 16 plus 25 is 41. And if I'm solving for C, that cancels out the squared. So I'm left with C is equal to the square root of 41. C being the hypotenuse. So as you see, it is not always a whole number. And that's okay. So for this particular problem, let's write it in red for fun. These are the fun things we get to do in math. We get to use different colored pens. So you have sine of theta is equal to the opposite side, which is 5 units long, and the hypotenuse, which is the square root of 41. And that cannot be simplified, and so I leave it as that. And that would be the sine of theta. So one of the key components is from the beginning, you've got to know which sides you are looking for based on which sides are included in the trig ratio they're asking about. Let's go ahead and do the last one. One more. Now with this, I'm going to give you a second to pause the video if you would like, so you can do an example on your own. Again, as a refresher, SOHCAHTOA. And when they ask me to find cosine of theta, I know that I'm focusing on this part right here. So I need to find the adjacent side and the hypotenuse. If I look at theta right here, adjacent is the side that's next to it. So that's my adjacent side. Now, I can Okay. I can eliminate this side that's 11. I know that's not adjacent because the hypotenuse is always the longest side, or the side that's across from the right angle. So I already know that's my hypotenuse. So from there, I know that this side is adjacent, and I know that that side is opposite. Now that I've labeled my three sides, I go back to the angle they're asking me to find, or the ratio they're asking me to find, which is cosine. So I need my adjacent side, and I need my hypotenuse. And again, that's because I know from my SOHCAHTOA that adjacent and hypotenuse are the two sides I need. So do I know my adjacent side? I don't. That's still a mystery. Do I know my hypotenuse? Yes, that is 11. You know one of them. I've got to find my adjacent side. The tool we have to do that, Pythagorean Theorem. So my a squared plus b squared equals c squared. Again, c is always my hypotenuse, so that will be 11 squared. The other two are interchangeable, so I'll just put a squared plus 6 squared. I have a squared plus 36, because 6 squared is 36. 11 squared is 121. So I've got a squared. Oops, let me go back just to show every step. So in order to get a by itself, I subtract 36 from both sides. The opposite of addition is subtraction. So that'll cancel that out. And then 121 minus 36 is 85. And then the opposite of squaring something or taking to the second power is to take the square root. That will cancel that out. So I'm left with a as the square root of 85. That being my adjacent side. That's the length. And that's not a whole number. That's not something I can simplify. So I'm going to leave that as square root of 85 because it tells us to not use a decimal approximation. So now I have my three sides. My hypotenuse is 11. My opposite side is 6. My adjacent side is 85. Sorry, square root of 85. And again, these two sides I need. The hypotenuse I already knew. And the adjacent side I just found was the square root of 85. So now I can write my final answer. The cosine of theta is the square root of 5 divided by 11. Not rounding, using exact values. So that's the process we go through in order to find sides of a triangle.